So good morning everyone and welcome to this lecture. We are in lecture number 3 and yes sir is dealing with collision sir. And in the previous class if you would remember we were discussing the type of collision depending on various factors. We had seen that on the basis of something known as a line of impact, the collision can be of two types. The first type of collision is known as the head-on collision, D, and the second type of collision is known as oblique collision. In head-on collision, before impact, both the velocities are along the line of impact, but as you can see, in case of oblique collision or 2D collision, if velocity of any one of these particles is not along the line of impact, the collision becomes collision in 2 dimension or oblique collision. We remember this, yes or no? Well, then we moved on to more interesting aspect of this concept of types of collision, and then we moved on to the concept of elastic or perfectly elastic collision on the basis of energy. In this perfectly elastic collision, the particles regain their original size and shape completely. There is no loss of mechanical energy. Kinetic energy of the system will remain constant. The final kinetic energy will be equal to initial kinetic energy. Do we understand this? Yes or no? And the momentum is conserved, and we had seen that something known as restitution, the coefficient of restitution, the velocity of separation divided by the velocity of approach, the value of E is 1 in this case. And as I told you, when the bodies are colliding, they deform and they reform. The force of deformation or the impulse of deformation here in this case is same as the impulse of reformation. That was a quick recap of what we had done in perfectly elastic collision. Everyone remembers this, yes or no? Now we move on to the exact opposite of this. What do you mean by exact opposite of this? The exact opposite of this was perfectly elastic collision. The exact opposite of this is the second type of collision, and we will call it perfectly what? Perfectly inelastic. My English is getting worse every day. Perfectly inelastic collision. Some people may also call it plastic collision, but that is not the term that we use. Perfectly inelastic collision. Perfectly inelastic collision. Now, what will you mean by a perfectly inelastic collision? You have to reverse everything that we have said in the previous case. Now we'll go one by one and write the different pointers here. So what will be a perfectly elastic collision? The first point that we wrote in perfectly elastic collision was they regain their shape completely. Yes or no? Do we remember? Here particles do not regain their shapes at all. They will not regain anything. They remain in maximum deformed state. They remain in maximum deformed state. They cannot regain their shapes at all, and they remain in their maximum deformed state. Do we understand it? They will remain in their maximum deformed state. This is just like if you have a wet piece of mud and you put that wet piece of mud on a wall, what happens? The wet piece of mud will stick to the wall. Yes or no? So you can understand that in this way, they will stick together. The body stick together in one dimension motion. The body stick together. The body stick together and move together. Stick and they move together. Kinetic energy is not conserved. Kinetic energy is not conserved. In fact, the final kinetic energy is less than the initial kinetic energy. Or you can also say this, the loss in kinetic energy is maximum. Maximum loss of kinetic energy happens in this case. Maximum loss of kinetic energy. Maximum loss of kinetic energy happens here. Are we able to understand what we are writing here? Yes or no? But if we talk about momentum, the momentum of the system is conserved. So you can write momentum of the system is conserved. Momentum of the system is conserved. So I can write m1 u1 vector plus m2 u2 vector will be equal to m1 v1 vector plus m2 v2 vector. Do we understand this? Yes or no? Everyone understands this? What I am talking about here? Kinetic energy is not conserved, beta. There is a loss of kinetic energy, but momentum is conserved. Momentum remains conserved here. I hope everyone has noted it down. Yes or no? Now, if I talk about the value of E, the value of E for this type of collision is 0. The value of E for this type of collision is 0. Now remember, E or 0 is equal to V2 minus V1 divided by U1 minus U2. Now if it is 0, this implies that V1 is equal to V2, or I can say velocity of separation is 0, or I can say both bodies move together. Both bodies move together. Do we understand this? They do not get separated, they move together. This is known as a perfectly inelastic collision. Everyone is able to understand this, yes or no? Everyone is noting this down. Now, I hope you have noted this down. I will just go back And since we have discussed something, I can also. Anyone has noted this down till up till here? Anyone has noted this down up till here? Shall I move on? Yes or no? Okay, now I'll just go back to the definition of this coefficient of restitution, and I would just like to tell you one more thing. We had seen that this value of E is the velocity of separation divided by the velocity of approach, v2 minus v1 divided by u1 minus u2. Now there is one more way in which I can write this value of E. This value of E can also be written in one more way, and that one more way is here. This E is also equal to impulse of reformation, impulse of reformation divided by impulse of deformation. So you can also write this, because I just hope that I can make you understand this. Impulse of reformation IR divided by impulse of deformation ID. This E is also written as impulse of reformation divided by the impulse of deformation. Have you noted this down? Yes or no? Everyone has noted this down? Yes or no? What is happening? Have you noted it down? I hope you can see this. Have you noted it down, beta?
No dawning, sir.
Noted down? Okay, you are noting it down. So this E, remember this one more definition of this E. It is impulse of reformation divided by the impulse of deformation. This is also one of the ways in which I can understand this value of E, impulse of reformation divided by the impulse of deformation. Now, having said that, have you noted it down, beta?
Yes, sir, done.
Now, having said that, beta, if you understand that E is equal to impulse of deformation divided by impulse of reformation, then you can understand here that since E is equal to 1, and this E is equal to impulse of reformation divided by impulse of deformation. Therefore, you will have impulse of reformation equal to impulse of deformation in case of perfectly elastic collisions. In case of perfectly elastic collisions where E is equal to 1, you can understand this in two ways. Velocity of separation will be equal to the velocity of approach, or you can also understand it in this way: impulse of reformation will be equal to the impulse of deformation. Impulse of reformation, oops, will be same as the impulse of deformation. Do we understand this, everyone? Impulse of impulse of reformation is equal to the impulse of deformation. Have you noted it down, everyone? Have you noted it down, everyone? Everyone has noted this down? Yes or no?
Done, sir.
Okay. Now, coming back to this perfectly inelastic collision, the value of E is 0, and from that value of E as 0, we understand that velocity v1 will be equal to velocity v2, that velocity of separation will be going to be 0, that both particles are going to move together. Now looking at the value of E as 0, can you tell me anything about the impulse of deformation or the impulse of reformation? Since we have just now covered impulse of deformation and impulse of reformation, can anyone tell me anything about impulse of deformation and impulse of reformation? Yes, this E is also equal to impulse of reformation divided by impulse of deformation. The value of this E is 0 because this is a perfectly inelastic collision. Can you tell me, knowing that the value of E is 0, can you tell me anything about reformation and deformation impulse? Knowing that the value of E is 0, can anyone tell me about impulse of reformation or impulse of deformation? Something is 0. Can you tell me what is going to be 0 here? Since the coefficient of restitution is 0, the impulse of reformation IR would be 0. Impulse of reformation is 0. Impulse of reformation is 0, and therefore bodies remain in their maximum deformed state. Bodies remain in maximum deformed state. Why they remain in maximum deformed state? Because bacha, there is nothing, there is no impulse, there is no force which is trying to bring them back to their original condition. So body will remain in their maximum deformed state. Impulse of reformation is 0. To just tell you some examples of perfectly inelastic collision, let us say I have a bullet, I have a block of mass m, a bullet comes with a velocity v, it strikes and it gets embedded inside this. Bullet strikes, bullet strikes and gets embedded. This is the example of a perfectly inelastic collision. Same thing can happen in this way also. You may have a block hanging like this. A bullet comes and it gets embedded inside. So such type of collisions would be known as perfectly inelastic collision. Do we understand this? Such type of collisions would be known as perfectly inelastic collisions. I'll give you 2 minutes to note it down. Then we move ahead. Now remember, We have seen the first two types of collision. The first one was perfectly elastic, or people simply call it elastic. The second one was perfectly inelastic. Now remember, this perfectly elastic or perfectly inelastic collisions, they exist theoretically, but no collision in this universe could be a perfectly elastic one. Similarly, no collision in this universe could be a perfectly inelastic one. So perfect elastic or perfect inelastic collisions are theoretically only possible. Practically, no collision can be perfectly elastic or perfectly plastic or perfectly inelastic. So these collision only exist in theory. They are not real. Then there is a third category of collision, which are the collision that we see in everyday life. Now, they are not perfectly elastic. They are not perfectly inelastic. They lie somewhere in between them. So now they are third category. The first one is perfectly elastic. The second one is perfectly inelastic. Then there is a collision which lies in between the two, and that is known as the inelastic collision. Third type of collision is known as inelastic collision. It is not perfectly elastic. It is not perfectly inelastic. Inelastic collision. So what happens in this one? The first thing that you must understand, in perfectly elastic collision, the bodies were regaining their shape completely. In perfectly inelastic collision, they were remaining in maximum deformed state. They were not at all recovering anything back. So what will happen in inelastic collision? The bodies regain their size and shape partly. Regain their size and shape partially, not completely. Partially. Some deformation remains in the body. Some deformation remains in the body. Some deformation remains in the body. That means they will try to regain their shape, but they will not be able to regain their shape completely. How does it transform into? Kinetic energy is not conserved because they are not able to regain their shape completely. Kinetic energy is not conserved. The final kinetic energy is always less than the initial kinetic energy. But in case of perfectly inelastic collision, the loss in kinetic energy was maximum. Here the loss is not maximum, but the loss is still there. I hope you understand this. Yes or no? Yes or no? Okay. Then the next point is momentum is still conserved.
Sir,
Yes, beta? Anything? Momentum of the system is still conserved. That means initial momentum m1u1 plus m2u2 will be equal to final momentum m1v1 plus m2v2. Now here I would take a pause and I would ask you, looking at what we have seen in perfectly elastic and inelastic collision. In a perfectly elastic collision, the value of E was 1. In a perfectly inelastic collision, it was 0. Can you now, using common sense, tell me what will be the value of E in this case? Perfectly elastic, it was 1. perfectly inelastic, it was 0. What will be the value of E for this? Yes, Bacha. The value of E, this collision lies in between the two. The value of E will lie between 0 and 1. The value of E will lie between 0 and 1. Now again remember, the value of E is V2 minus V1 divided by U1 minus U2. It is less than 1, so I can say that. What I can say? The velocity of separation would be less than the velocity of approach. For this particular case, the velocity of separation would be less than the velocity of approach. Now, same thing I can say for E in terms of impulse of reformation and impulse of deformation. Now, this E is also equal to impulse of reformation divided by impulse of deformation. The value of E lies between 0 and 1. Now, can you tell me what will be the relation between reformation impulse and deformation impulse? Remember, in the case of perfectly elastic collision, impulse of reformation and deformation were equal. In case of perfectly inelastic collision, impulse of reformation, it was 0. It was not reforming at all. Can you tell me what will be the value of, or what will be the relation between reformation and deformation in this case? What will be the value of reformation and deformation in this case? Impulse of reformation will be less than the impulse of deformation. Therefore, it will not be able to regain its size and shape completely, and some amount of deformation will always remain there. I hope you understand this. So remember the point that I have said, no collision is perfectly elastic, no collision is perfectly inelastic. All the collisions lie somewhere between elastic and inelastic nature. I hope you understand this. Everyone understands this? Yes or no? No or yes? Okay. Everyone has noted this down? Yes or no?
Yes, sir.
Then we can write all these things together in one table if you want to. So in one table you will have the three types of collision. On the extreme left side you have a perfectly elastic collision. On the extreme right side you have the perfectly inelastic collision. Sandwich between them is the inelastic collision. In a perfectly elastic collision, kinetic energy is equal. Perfectly inelastic or inelastic collision, kinetic energy is not equal. The coefficient of restitution is equal to 1 in one case, is less than is between 0 and 1. In the third case it is equal to 0. Everyone understands this? So this is just everything written in short in one table. I hope you understand this. Yes or no? No or yes? Then you can have the second thing. Same thing written in a different way. You don't have to write everything. You just have to understand the value of E and this. And the third thing is examples. If you want to write the examples, you can write them. Otherwise, if you have understood this, there is no point of writing this. I'm just showing it. I'm just showing the same thing in a tabular form. If you want, you can write it in the tabular form. I will give you 2 minutes to note this down. Then we move on and we write the next heading, perfectly elastic head-on, perfectly elastic head-on collision. We'll just go through what is a perfectly elastic head-on collision, and we can take a very simple example of perfectly head-on elastic collision by a diagram. Now, as you can see, u1 and u2 are the velocities. Initial velocities v1 and v2 are the final velocity. So in order to solve this, what you can do, first case, you can apply the law of conservation of momentum. And remember, I am taking one direction as positive. So this direction, I am taking it as positive. And in this case, all the velocities are in one direction. So I can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Do we understand this? This is the equation that I can write from here. Do we understand this? Yes or no? Then I know the value of E is equal to 1. From here I will get V2 minus V1 will be equal to U1 minus U2. Yes or no? Solving these two equations, I should be able to get the value of V2 and V1. This is all that you need to do to solve any question. If you want, you can use the third equation, which is not required. If you use the first two equations, you should be able to solve the question and get the answer. So you should only use equation number 1 and equation number 2, and you don't require to use equation number 3. In any case, equation number 3 is law of conservation of kinetic energy. Kinetic energy remains conserved. It's not law of conservation of kinetic energy. Kinetic energy remains conserved, so I can write half m1 u1 square plus half m2 u2 square will be equal to half m1 v1 square plus half m2 v2 square. Do we understand this, what I have written? Yes or no? Okay, so using these 2 or 3 equations, equation number 1 and equation number 2 to be very precise, you should be able to find out the value of V1 and V2. Now you can do a special case here, and most of the question that you are going to encounter will be coming from this special case. What is the special case that we are talking about? Special case that we are talking about. So you can write this special case. special case number 1. Special case number 1. And the special case is M1 is equal to M2. Both the masses are same. Now, if both the masses are same, what is going to happen is that your V1 will become equal to U2 and your V2 will be coming as equal to U1. So what it means is whenever two bodies of equal masses, they collide and the collision is perfectly elastic, they interchange their velocities. So that is what you need to remember. If two bodies of same masses collide elastically, that means the collision has to be perfectly elastic, then they interchange their velocities. This is a very important result that you must remember, that if you have two bodies of same masses colliding with each other elastically, then after collision they will interchange their velocities. Now, if you have understood this, can you solve this question? Question number 1. This is a perfectly elastic collision. That means the value of E is 1. The value of E in this collision is 1. A 10 kg body coming from behind with a velocity of 50 meter per second is colliding elastically, E is 1, with a similar 10 kg body but moving with a velocity of 20 meter per second. The collision is perfectly elastic. Can you tell me what will be the velocities of the two bodies after this collision? What will be the velocities of these two bodies after collision? What will be the velocities of these two bodies after collision? Yes, Bacha, I'm waiting for your answers. Can you tell me what will be their velocities after collision? It's a perfectly elastic collision and we have written something just now. What will be the velocities of these two bodies after collision, my dear friends? Yes. Anyone can tell me what will be the velocities of these two bodies after collision? The behind body is moving with a velocity of 50 meter per second. The body which is ahead is moving with a velocity of 20 meter per second. After collision, what will be their velocities? Yes, anyone? After collision, they will just interchange their velocities. As you can see, velocity of the first body becomes same as the initial velocity of the second body. The final velocity of the second body is same as the initial velocity of the first body. So this is what I had to make you understand, and this is the best example for you to see this. Do we see this, everyone? So this is what you got to remember. More than 90, 95, 98, 99% of the question that you will have will come in this category. So we will continue with these questions. In the next class, we will see more examples of inelastic as well as elastic collision, and we will solve the questions in the next class. So I'll see you there. Take care and God bless you all. Everyone understood what we have done today in today's class? You should remember all these small pointers, beta, because in this particular chapter, you are not going to get numericals as such. You are going to get theoretical questions. So please remember all those points that I have given it to you. I have given them point wise so that it helps you in remembering them. Take care and I'll see you tomorrow. Bye bye, everyone.
Bye, sir.